Chapter 11, Section 2, the surface area, abbreviated here, of prisms and cylinders. Now, here we're going to start getting into a lot of vocabulary. You can abbreviate where necessary, but make sure you have the diagrams, make sure you know what all of the terms mean. A prism is a polyhedron with two congruent parallel faces, so the top and bottom in this case, and those are called our bases. The other faces are called our lateral faces, so those are these arounds, those are the rectangles in this case. You can name a prism using the shape of its bases, so this would be a pentagonal prism because it's made up of pentagons. This would be a triangular prism because the bases are triangles. So here we have our lateral edges, our lateral faces going all the way around, and our bases here and here. The altitude of a prism is the perpendicular, has to be perpendicular, segment that joins the planes of the bases. The height of a prism is the length of that altitude. So essentially they mean the same thing, but altitude is the actual line segment, height is the measure of that segment. A prism may either be right or oblique. Most of the ones we're going to work with are going to be right, so they're going to be standing straight up. But there are cases where they're oblique, and you have to find the distance from this base if you extend it perpendicularly up. Or, of course, you could figure out something along those lines, but you need to have the vertical height, the perpendicular height. In a right prism, the lateral faces are rectangles and the lateral edge is an altitude. In an oblique prism, some or all of the lateral faces are non-rectangular. In this book, in the textbook that we're going to be using, you can assume that something is a right prism unless it's otherwise stated or it's pictured like this. So even if they don't give you the right angle here, if it looks like a right prism, it is a right prism. The lateral area of a prism is the sum of the area of just the lateral faces, so just these going around. The surface area is the lateral area and the area of the two bases. So the surface area is the area of everything. The lateral area is just the sum of the areas of the lateral faces, so not including the bases. So if you want to make a note, not including the bases. Now, when we're finding the lateral area, one way to do it is to find the perimeter and then multiply it by the height. Now, realistically, whenever you're finding the surface area, all you have to do is find the surface area. This is called a net image. When you unfold the three-dimensional image, all you have to do is find the area of each of the polygons that's making up the space figure and then add them all together. That's usually the easiest way. Sometimes you'll see formulas, but it's up to you. So here you can see in this example, we have a triangular prism. If I asked you to find just the lateral area of that, well, here this has three rectangles that are making it up. We can see that this back one has a length of 4 and a width of 6, so that's going to be 24 centimeters squared plus 3 times 6, because we're assuming it's a right prism. That's going to give us this left-hand one, so 18 centimeters squared. And then this front one, well, we need to know what the length of this side is, but we can see it's a right triangle, so it must be 3, 4, 5. That's a Pythagorean triple. So we have 5 times 6, which gives us our 30 centimeters squared, which means that the lateral area is going to be 24 plus 18 plus 30, which gives us 72 centimeters squared. Now the surface area, the total area of all of the polygons, is going to be that lateral area plus the area of the two bases, so our two triangles. Well, in order to do that, we need to know what the height of the triangle is. Since it's a right triangle, we can see that the base could be 3 and the height could be 4. So 1/2 of 3 times 4 gives 1/2 of 12 gives us 6. So the top has an area of 6 centimeters squared, which means the bottom also has that area. So we're adding an additional 12 centimeters squared, and that's going to give us a total area of 84 centimeters squared. Now a cylinder is a solid that has two congruent parallel bases that are circles, and an altitude of the cylinder is the perpendicular segment that joins the planes of the bases. The height is the measure of that altitude. So again, we have right cylinders and oblique cylinders, but you can assume that it's a right cylinder unless it looks oblique. In a right cylinder, the segment joining the centers of the bases is an altitude, so from here to here would be the height. In an oblique cylinder, the segment joining the centers is not perpendicular. These would not be perpendicular to the planes containing the bases, but we're going to assume that unless it looks oblique, that it's a right cylinder. To find the area of a curved surface of a cylinder, visualize unrolling it. So like a roll of paper towels. The area of the resulting rectangle, so this shape, is the lateral area, whereas the surface area is the lateral area plus the area of the two bases, which are two circles. However, we can find formulas for these areas by looking at the nets. So this is going to be our net figure. This is the easiest one to look at. So it's made up of a rectangle and then two circular bases. The lateral area, this one is a nice formula to just memorize these two, is going to be 2 times pi times the radius times the height. And the surface area is going to be the lateral area plus 2 pi r squared, because the area of one of the circles would be pi r squared, but there's two of them, so 2 pi r squared. And we get the pi times r times the height, because 2 pi r is going to be the circumference, so that's going to give us basically this measure, and the height is going to give us the rest of the rectangle. So that's where the lateral area formula comes from.